Okay, I changed everything. I changed the dip switches over to English. Alrighty, so I'm going to go ahead and coin up and start. Coin and start. That is center, right, and left. Trackball does not seem to be working. It was working a minute ago. Alright, into test we go. Yeah, the trackball quit working. It goes left and right. It does not go vertical. It don't go vertical. It goes horizontal, but not vertical. Okay, that just happened. Because I had tested this when I changed the dip switches, and it was working just fine. But it took a crap. MC14 584. Let me grab one of those. If I can find them. Remember, I moved everything all around. There they are. MC14 584. It might just be one of these MC14 584 chips. I don't know. I'm going to have to look at the schematic a little bit and really look at the trackball circuitry and figure it out. I don't think it's as easy as one of these. It might still be. I don't know. Alrighty. I'll be back. Gotta fix the old trackball. Okay. Move that guy down to there. Change this to 1 volt. We're going to go through this one together. Let's see if we can't figure this trackball thing out. It's extremely early, so pardon me if I sound like I just woke up, because I just woke up. And I need to turn the monitor on. I switched over to the G07 because that other monitor is such a, it needs to be rebuilt. It needs a new tube, I think. So I did hook the G07 back up. Oh, goodness. And there it is. It looks beautiful. Okay. I do have to turn this light on. I don't have a choice. Okay. I printed off, this is the trackball schematic, basically. I printed off a little bit of it. Should be enough to get this done. So it looks like our trackball movement. Let's put it in test. Yeah, the vertical is the problem. So vertical from the trackball, clock and direction are on first. They go through a cap. See 78 and 79. Which I'm sure the cap's not a problem. Anyway, vertical direction is on pin 1 of this guy. This is vertical direction. That doesn't look good. Let's look at horizontal direction in contrast. It doesn't really look good either. You can clearly see a square there. This just looks like a bunch of nonsense. I'd like to see what this looks like on my other scope. Everything always looks more clear on this guy. I'm really curious. Alright. And 9. Yeah, look at that. Look how, okay, I don't know if you can see that, but that looks so much clearer. I'm gonna crank it. Zoom it in a little bit. Zoom it in a little bit more. Even more. Even more. Super slow. But there it is. Nice signal. I'm going to give you a view of my good scope up here. Because it's where it's at. Okay. Now I'll show you what the signal looks like when you move the trackball. Okay. Let's see. See how that makes a nice chopping square? And then it's basically, this is like a CMOS Schottky part. It makes it a nice clean square wave. That's vertical, that's horizontal direction right there. And that's horizontal direction. What about horizontal clock on 13? This is horizontal clock. Same thing. And it is turned into a nice square wave. Now let's look at vertical. Vertical is pin 1, vertical direction, pin 1. Okay, vertical 3.3, 10K, 10K. It's the same. Okay. And then 5 out to 6. There it is, see that? So our problem is not this chip. That looks great. Now we go to this mux. Everything dumps into this mux. It's at D9. This guy right here. Everything dumps into here. Let's just look at the vertical. Vertical stuff is direction and 2 and 2 and 3. Let's check out pin 4 is our output for vertical direction. Yeah, that looks good. That's vertical direction right there. It's a perfect looking square. Now let's look at vertical clock on pin 7 output. That looks great. No problem. Okay. And just for fun, let's look at the other two on pin 9. This is horizontal. It looks great. And 12. Looks great. Okay. That's doing its job. Then we come up and they go to a 74 flip-flop. The vertical direction and vertical clock signal go together. And the horizontal clock and horizontal direction go together. Both to the data pins and clock pins respectively of 74. And vertical goes to J8, the low side of J8. This guy right here, the low side of J8. So 1 and 4 should be tied high. And they are. D is on pin 2. And there's D. Here's your data. And here's your clock. Here's the output. That looks good. Output. That looks good. Okay. So, now we move on to this 191 counter. This Q on 5 is the only one we care about. It's the only output coming off of this guy that we care about. The output at that 74, and that's it right here. which is a nice looking perfect square. Then we go to the 191K8. 191. And vertical clock goes into pin 14. Vertical clock. There's vertical clock. Okay. Up, down, count goes to pin 5. There it is. Okay. Controller load pin is on 11. And it's just it's a pulse. You can see it. Okay. Alright. Outputs of that are 3, 2, 6, and 7. Three, 2, 6, and 7. Okay. I mean, so far that looks fine to me, right? So let's look at the outputs on K9, because that's the vertical, that's the horizontal, and it looks pretty much exactly the same, right? The vertical counts, you can see them. Yeah, that looks just fine. Then we have L9, which is a 244, and that's where the CPU scans and reads all of what's going on in that circuit. So that 244 is at L9, which is right here. This is the that's not that. You can see that there are low going pulses here. That's the enable to this guy. Okay. So you know what I want to do is I want to hook up to this with this guy. Okay. Hook up to L9 and make sure that this is doing its job. And the CPU is getting proper data. Okay. Oh, I need 3. I need enable. Alright. Yep, I need 3. 1, 2, 3. we're going to go 2 volts. Nope. 2.25. volts. Okay. That's your enable. And then we have, let's do, this is an N. This is an this isn't working. That's looks like it's floating, this input. Or it's just high all the time. Okay. It's coming back down here. Let's come back down here. Look at this guy again, because this is where I'm doing my business. I'm just moving this thing and you can see the change when I move it. Alright. Move on down the line. I'm curious about 8 out to 12. And you can see it going low down here. And let's look at 11 out to 9. And let's look at 13 out to 7. When I move it, I can see this goes low and this goes low with it. That's 13 now, 15 out to 4. It's actually 15 out to 5, isn't it? Yeah, 15 out to 5. That looks fine. Now, I know it's not my trackball because I plugged another trackball into it. Okay, so far everything looks great. Boy, it's really kind of impossible to see if that's really working right like that. Alrighty, let me think about the best way to go about this. I'll be back. Alright guys, just for fun I decided to take a 157 and put it over this guy. And oh, it's going to be impossible for me to I can't do it. Just trust me, this 157 is no good. I think. Yeah, let me mess with this. I'll be right back. Alright guys, I got a new mux in the board, 157. And we are in test mode, and I did put the Nintendo monitor back on here because it's just got the best picture. So the G07 needs to be capped big time. It was doing this kind of blooming stuff, you know, and just looked like crap. So I got this guy back on here, and you'll see our trackball now is up, down, good, left and right. So that fixed that. So this thing appears to be 100% now. But I got to give this thing a good burn in. And I'm considering removing my ROM sockets and keeping them. As much of these that I go through, I may remove those and put them back in my stock. I'm not sure yet. But I'm going to give this a nice long, most of today, 5-6 hour run test. Let's set the camera up and do a little testing, do a little button testing and all that kind of stuff. And put a bow on this one. Call it good. All right. Let's go ahead and coin this baby up. I know you're right by the furnace. The trackball ain't working again. The trackball quit working. Guys, the trackball is dead again. What in the world? What is going on? All right, let me look into this. Guys, I think I found the problem. It's not any of our chips. This capacitor that's vertical direction, right? Vertical direction comes through and passes through C78. It passes through it. And then into this guy. Check out C78. That's how that was. I don't know if somebody desoldered that before and forgot to solder it. That's the problem. So I'm going to solder that back down into there, and we should be good to go. You know, very strange. Very strange that that is completely desoldered. Alright, let me solder that back up and we'll test it again. Okay, so I've resoldered that guy. You can see right there, it's resoldered. And it's back to working. As you can see, yeah, up and down and all around. Very strange, and that looked like it had never been soldered. It did not have any kind of flux residue around it at all. It just looked like it had never been soldered. That is so weird. Alright, anyway. Let's get back to our test. This thing now should be 100%. Alright, so we will go out of test. Okay, so I will once again coin this baby up. Coin. Cursor all over. Center base. Left base. And right base. Now we'll just let ourselves meet our doom. And as always, guys, I appreciate you watching. We're going to let Missile Command take us out. We'll see you on the next repair, guys. Thanks a lot.